Hello, welcome to Flipped. So today we'll be talking about graphite and diamond. Graphite is an allotrope of carbon, okay, which means it's different ways, okay, to arrange the same element, okay, to give different structure. So in the case of graphite, it's being arranged in the sheets manner, okay, basically sheets of carbon atoms with weak intermolecular forces between the sheets. So for example, this is sheet 1, okay, this is sheet 2, okay. And you can see that between them, there's this weak intermolecular forces that are very easily overcome. Okay, and now the carbon sheets can slide over one another. In real life, this is in pencil. So when we write on paper using a pencil, a layer gets displaced, okay, on the piece of paper from the pencil. Okay, basically one sheet is being placed on the paper followed by the other. Okay, and that's how the carbon sheets slide over one another because they have very weak intermolecular forces. And this is a very important property called a lubricating property, okay, which can be used in lubricants. So lubricating property only applies to graphite. Another property of graphite is electrical conductivity. Why? It's because in each sheet of carbon, okay, one carbon atom is bonded to 3 other carbon atoms to form a tessellated hexagonal ring. So this is something like this, okay? It's a benzene ring, basically, okay? You can see that, for example, this guy in red, okay, it's being bonded to 1, okay, maybe I use a different color, 1, 2, 3. Okay, you can see that it's being bonded to 3 other carbon atoms, which will look like this, okay? And you can see that when they share the electrons, this red carbon that we talk about, okay, this guy, the same guy here, has 1 additional electron that's not being used up, okay? And this one is what we call a valence electron that is not used in bonding. And it can be delocalized and is free to move about. So if all the carbon atoms, this one, all the carbon atoms in the whole graphite structure gives up just 1 valence electron, it can form a sea of delocalized electrons. And these electrons are now mobile and are able to carry charges. And that's why graphite is an electrical conductor. Because of this 1 extra valence electron that's very unique to this graphite structure. On the other hand, when we learn about diamond, okay, we learn that graphite does not have the two properties of, diamond does not have the two properties of graphite, which are lubricating and electrical conductivity. Why? Okay, first of all, we start off with explaining that diamond is also an allotrope of carbon because in diamond, carbon atoms are arranged differently from graphite. Okay, but in the case of diamond, there are no carbon sheets, okay, like in graphite. So there's no lubricating property because there's no weak intermolecular forces to be easily broken to slide over one another. Also, in diamond, each carbon atom is bonded to 4 other carbon in a tetrahedral structure, instead of in graphite is bonded to 3 other carbon atoms. So now there's no extra valence electron to move about, and hence it is a non-electrical conductor. Okay, in the case of this guy using this diamond structure, if you look at this green carbon atom here, we can see that it's being bonded to 4 other carbon atoms. 1, 2, 3, 4. And so when we draw it out, okay, this is maybe I use green. This green carbon here, okay, it's sharing its electrons with 4 other carbon atoms. So there is no extra electrons. Maybe for the green one, I use a dot. Okay. Whereas for the other electrons, I use white. Other carbon, I mean. Okay. So you can see that it's being totally used up. Okay, and this is not just for the green atom, it applies for all the carbon atoms in the structure as well. So there are no valence electrons as with graphite. Okay, and so with no valence electrons, you cannot carry charges and there's no electrical conductivity. However, on the other hand, diamond has its own unique property, which is hard and brittle. So it's used in drill tips, okay, or can use as diamond blades. Basically, this is a drill tip, okay, or drill bit, okay. There are 2 ways to call it, drill tip or drill bit. Basically, this is a drill, okay, this is the tip of the drill that you can drill into the ground. These are all diamond, okay, so it's a very expensive piece of equipment. this diamond is so hard, okay, that it can break through any other compounds, any other substances. Okay, that's why diamond is very useful to help us break the ground. Okay, and also can be used as a diamond blade, which is to cut structures that are very hard to cut, like rocks, etc. Okay, so as a recap, okay, we go back to here. Basically, there are 3 properties you have to know. Graphite is lubricating. Second, graphite is electrical conductor. Finally, diamond is hard and brittle. Okay, and you have to know the factors leading up to their individual properties. Okay, and that will be all for graphite versus diamond.